This is a worked solution to AQA Physics P2 June 2014 higher tier paper question 6. Isotopes are different versions of the same element. They have the same number of protons but different numbers of neutrons. So the thing they have in common is that they have the same number of protons. In the process of nuclear fission, nuclei split. You cannot write atom split because it is the centre of the atom, the nucleus, that splits. The next part of the question says, inside which part of a nuclear power station would molybdenum be produced? Well, it says the isotope molybdenum-99 is produced inside some power stations from the fission of uranium-235. So it's really asking where does the fission happen, and this is in the nuclear reactor, or the reactor core. 6c wants us to recognise that while the total number of protons and neutrons has remained the same, the proton number has increased by 1 from 42 to 43. The type of radiation responsible for this type of change is beta radiation, because in beta radiation a neutron in the nucleus decays to form a proton and charge is conserved by emitting an electron at the same time, which is the beta particle. So in this case the radiation emitted is beta, and the explanation is that the proton number increases by 1. The term half-life refers to the time taken for the number of nuclei to halve, or the time taken for the count rate or the activity of a radioactive sample to halve. So it's the average time for the number of nuclei to halve. So technetium-99 is used in medical physics, and it's produced by the decay of molybdenum-99. A technetium generator will produce sufficient technetium until 80% of the molybdenum nuclei have decayed. That means that 20% of them remain, and if we started off with 100,000, 20% of 100,000 is 20,000. So 20,000 remain. And the time taken for 20,000 to remain, if you use a ruler and go carefully along this line here, you can see that it meets our curve there, which is 6.2 days. The risks of using radioactive substances in medicine are that radiation causes ionizations, and if the cells of the body are ionized, this may harm them or cause mutations to the DNA or cause cancer or kill healthy cells. Doctors still use radioactive substances despite the risk, because in some cases it may be the only procedure available, or it may be that the benefits of the treatment outweigh the risk.